All right, so question number 7 says, um, a sequence of figures is made um, by joining polygons with sides of unit length. The first three figures in the sequence are shown below. We're asked to draw figure 4 of the sequence. Well, I guess when you're doing the exam, you can try and be nice and neat. I'm gonna just try and do my best to draw it. All right, so this is the bottom. All right, so I'm guessing the fourth figure in the sequence would look something like that. Um, Guys, I guess you could make a special effort to try and draw the thing to scale, mean taking measurements and you understand and make an effort to draw something decent. But I won't do that right now. So that's 2 marks. Next, we're asked to study the patterns of numbers in each row of the table below. Each row relates to one of the figures in the sequence of figures on page 23. It said some rows have not been included in the table. We're to complete the rows numbered I, and triple I. All right, so we're to study the pattern of numbers. All right, and see, what are we seeing in the pattern? All right, so the number of outer lines of unit lengths, you'll notice that the figure number is the same as the number that this thing starts with, 2 in the middle, and then the numbers to the right are going up by what? By 2, or it's 2, all right, yeah. It looks like it's the first number and the last number multiplied by 2. Or you could say really, it looks like it's going up by what? By 2. Anyway, let's see. The perimeter is going up by 3. The perimeter is going up by 3. So if so be the case, it means that 6 is would be, first of all, 6 would be here, plus 2 in the middle, and then 6 times 2, I'm guessing this would be 12. All right, so if this is going up by 3, the general term TR would be equal to 3R plus 2. So if R is 6, this is going to be 3 times 6 plus 2. So this would be 20. All right, that's what I'm seeing. Or it looks like just by adding the numbers over to the left, 6 plus 2 plus 12, you would get the 20. That's what it looks like to me. So you probably didn't have to go through this fanciness. All right, we're told that the perimeter is 65, and we're asked to determine the figure number and the number of what? Lines of unit length. Now, let the figure number be X. So therefore, Tx would be equal to 3x plus 2, and this would be equal to 65. So 3x would be equal to what? 65 minus 2. 3x would be equal to 63. Divide both sides by 3, and we're going to get x is equal to 21. So this is 21. This is 21 plus 2 times 21, which is what? 42. When you add up all of this, you should get 65. So this plus this is 43 plus 2, 65. So that is correct. So if this is n, this is going to be n plus 2 times n. and this is going to be 3n plus 2. It's going to be 3n plus 2. Let's see what next. Show that no figure had a perimeter of 100 units. We're to show that no figure had a perimeter of 1 unit. Now, the way I would do this is I would assume that the nth figure, assume that the perimeter of the nth figure is equal to 100. So it means therefore that 3n plus 2, which is the perimeter of the nth figure, is equal to 100. Now, if n comes out to be a whole number, n is the figure number. The figure number must be a whole number. The figure number must be a whole number. If n comes out to be a whole number, the perimeter can be 100 units. If n comes out to be a fraction or a decimal, it means that the figure cannot, that there's no figure with a perimeter of 100 units. Let's find out. 3n is equal to 100 minus 2. 3n is equal to 98. Then I'm going to divide both sides by 3. And when I do that, I'm going to get n is equal to 3, 2, and 0.67. Guys, n is a figure number. You can't have a 32.67 figure. It must be a whole number, or it must be a whole number. If it's not a whole number, so therefore, since n is not an element, let's use mathematics notation. Since n is not an element of the set of what? Whole numbers, 100 is not the perimeter. All right, no figure has a perimeter of 100. No figure has a perimeter of 100 units. All right, I'm stopping here.